question. Yeah, today we're looking at how can we convert a word equation into a chemical equation. But now we need to understand that the chemical equation is made up of the chemical formulae. The chemical equation is made up of the chemical formulae. That's why it was very important at the beginning that I had to give you on how to write the chemical formula, because in this chemical equation, the chemical equation just be made up of the chemical formulae as well as the signs such as plus and the arrow. Now, to remind you, the chemical formulae, the things that we take care of are things such as the symbol of elements as well as the valences. Those are very vital things that we have to remember as you venture into writing of chemical equation. You should be able to retrieve the valence of each of the element radical that are present, as well as radicals that are present in the chemical formula. So number one, we are told that we are reacting carbon plus oxygen. Then we are forming carbon dioxide. That is the first reaction. The first reaction is we're reacting carbon with oxygen, and what we are forming is carbon dioxide. Now, I will urge you that whenever you are doing this task, you need to have the periodic table, because from the periodic table, that is where you'll be able to get a chemical formulae of chemical symbols of elements, as well as the valences of those elements. So from the word go, we know that now this is a word equation. So converting it into a chemical equation, what is the chemical symbol for carbon? The chemical symbol is C. Now, carbon is a monoatomic element. When I say a monoatomic element, I'm talking about an element which can exist on its own as a single element. So we're going to have carbon and then plus oxygen, the symbol is O. But the oxygen is just like nitrogen, hydrogen, fluorine, chlorine, bromine, and iodine. These are diatomic elements. That means when you're writing oxygen, you have to put a 2. Today we are not doing the balance. Today we are not doing the balance. Mari or Mike is making what are you doing? Okay, so oxygen is a diatomic element. That means when you're writing, you have to put a 2. Now, what are we forming? We are told that what we are forming is a carbon dioxide. But we know that carbon dioxide is CO2. But how is that arrived at? How is carbon dioxide written as CO2? So I will take you back to how we can form a compound that is made up of carbon as well as oxygen. The rules for writing the chemical formula. So you're going to have carbon here in the oxygen without writing a 2, just write them as individual elements. Then what is the valence for carbon? Carbon is in group 4, so the valence will be 4. Oxygen is in group 6, so 6 from 8, the valence is 2. So now how do you write the chemical formula? We're going to bring these elements together and interchange their valences. So we're going to have C here, and the 2 now will be written as a subscript, then oxygen here, and the interchanged valence will be written as 4. But because these numbers can be reduced, there's the smallest number we can use, which is a 2 here. There's another number we can use, the same number can be reduced, so that carbon will be written then 2 into 2, 1. If the valence is 1, you don't write it down. Then we're going to have oxygen here, 2 into 4, which is 2. So carbon dioxide will be written as CO2. So the carbon dioxide, how to write the chemical formula is CO2. That is how you can complete. That's how you can convert the word equation into a chemical equation. So we have carbon plus oxygen to form carbon dioxide. That is the first example. I'll just do 2 from here. Then we go to learn how we can complete now the chemical equation. Then B, we have aluminium plus oxygen. So we have aluminium plus oxygen. Then we form aluminium oxide. Aluminium oxide. Aluminium oxide. The same thing that we did for the first equation, it is the same thing that we're gonna do even for the second one. The first thing that we have to do is identify the elements that are written, or identify the entities that are in here. We have aluminium, so we know how to write. From the periodic table. The symbol for aluminium is written as Al, capital L and a small capital A and a small L. And then this one is reacting with the oxygen. It is reacting with oxygen, like the way I had said. Oxygen is a diatomic element. If it is a diatomic element, when you are writing the symbol, you have to put 2. That is what we are forming. That is what we are having as oxygen. Now, what are we forming? We are forming aluminium oxide. How do we write aluminium oxide? That's the task that we have. These ones, you can get them from the period.
All right.
I lost connection.
Okay, bye. I'm deep.
Hold up.
Oh, he's come back.
I lost connection.
Yeah.
I'm back now. The network these days hasn't been that strong. Okay, so now the question that we have at hand here is how can we now write the aluminium oxide, because aluminium oxide is never found on the periodic table. But the same procedure that we had followed when writing carbon dioxide is the same procedure that we're going to follow here. We know that what we are combining is aluminium, so we're going to have Al and the oxygen. Aluminium is in group 3, so the valence is 3. Oxygen is in group 6, 6 from 8, the valence is 2. So when you combine these two and interchange the valences, you're going to have Al. The 2 which was on oxygen will be written now as a subscript, and then followed by oxygen. The valence 3, which was an aluminium, will be written after oxygen. So it's Al2O3. So that is the chemical formula for aluminium oxide, Al2O3. That is how we can do for aluminium oxide. Now, what about the second one? What are we having on the second one? Or the third one? So the third one, C, is talking about sodium plus water, which is called water. So we have sodium. We have sodium plus water. What we are forming is sodium hydroxide. Sodium hydroxide, and then plus hydrogen. We are just converting. So we have sodium plus water, and we form sodium hydroxide plus hydrogen gas. So from the periodic table sodium, we know that it's driven from a Latin name, nandium. So the chemical formula is Na. Plus, water is never found on the periodic table, but we know that water is written as H2O. So it's not putting. Let me call it again. I'm having class. Let me call it. Okay, so it's sodium plus water, and then we know that water is H2O is never found on the periodic table, but it's something that you can construct. Then what are we forming? We are told that we are forming sodium hydroxide. Sodium, it's a metal, Na, but what about hydroxide? Hydroxide is a radical. But because sodium has a valence of 1, because it's found in group 1, and then hydroxide is the radical, which is OH with a valence of 1, so there's no need of following the procedure like the way we have done for that. So I'm just going to say NaOH, because Na has a valence of 1, and OH hydroxide has a valence of 1, so we're just going to write it like that. Then what are we having? Also hydrogen gas. Hydrogen, nitrogen, oxygen, fluorine, bromine, iodine, those are diatomic elements. That means when you're writing them, you have to put a 2 as a subscript. But hydrogen, the formula, the symbol is H, but it being a diatomic element, you're gonna put a subscript as a 2. So that's how we can convert sodium plus water to form sodium hydroxide plus hydrogen. Sodium is Na, water H2O, sodium hydroxide, sodium Na, valence 1, hydroxide OH, valence 1. That's why we have not put any of the subscripts like the way we did above. Then hydrogen is H according to the symbol in the periodic table, but this is a diatomic element. That's why I have put a 2 as a subscript. That is how you can deal with this. Then the last one is so chemical formulae is a very, very important approach that you have to first know before you get to know how to write the chemical formula. You should first know how to write the chemical. You should first know how to write the chemical formula before you get to struggle on how to write the chemical equations. Chemical equations will just take you back to the construction of chemical formulae. The last one, according to the preparation that I've had, D, it's zinc plus sulfuric acid. So we have zinc plus sulfuric acid. Sulfuric acid. Then what we are forming is zinc sulfate. Zinc sulfate. And then plus sulfuric acid plus hydrogen gas. Plus the hydrogen gas. So that is the fourth and last example that we have on how to convert word equations to chemical equations. So how are we supposed? What are we supposed to do? Remember, zinc is a metal which you can zinc is a metal whose symbol and the valence you can extract it from the periodic table. So zinc is written as Zn. Then plus sulfuric acid is a compound that is made up of hydrogen as well as sulfate. Now, in case you don't know how to write the chemical formula for sulfuric acid, so we're saying it is made up of hydrogen and the sulfate, it's SO4. There's the valence for hydrogen is 1, the valence for sulfate is 2. So when you combine these two entities and interchange their valences, we're gonna have hydrogen here having a 2 here and the SO4 having a 1. But because the valence is 1, you don't write it. Okay, but what do you do if the valence was something other than 1, such as a 3, such as a 4? Because that valence was going to represent everything, was going to stand for everything on the sulfate radical, so we're going to put the brackets like that. I'm just saying if the valence here was a 3, we could have put the brackets and then we put a subscript like that. Because without this, it's gonna be 43, and that could have been wrong. So sulfuric acid is H2SO4. So it's zinc plus sulfuric acid, which is H2SO4. What are we forming? We are forming zinc sulfate. So what happens here is this hydrogen will be removed, and then the zinc goes to occupy the place. And that is what happens. This hydrogen failed to pay the rentals, so the zinc is going to occupy the house and then sends the hydrogen into exile. But now zinc has a valence of 2. Sulfate also has a valence of 2, so there is no need of struggling on how we're going to write. We're just going to combine them, zinc, sulfate, like that. We're just going to combine them because both of them have the same valence, which is 2. So we're going to write is zinc, sulfate, and then plus C. We are told that hydrogen is formed. So this hydrogen, which is a diatomic element, will have a 2 like that. And that's how we can convert a wave equation into a chemical equation. That is how we can do it. Any question? Any question, Luca? Okay, so now let's see how we can complete the chemical equations. How can we complete the chemical equations? We were given written word equations. Then the task that we had was just to convert those given word equations and then write them into chemical equations. Now, the task at hand is they have started for us the chemical equations. So the only thing that is required of us is to complete them. When we are given what is starting, how can you know what is likely to be formed? How can you know what is likely to be formed. So the next step is completing of chemical equations. So we say complete chemical equations. Completing of chemical equations. The first one is sodium plus hydrochloric acid. So we have Na plus hydrochloric acid is written as HCl. So what do we do? You look at the sodium here, which is a metal coming from the periodic table in group 1. The same thing that we've had in the last equation, sodium is going to remove the hydrogen from the compound because hydrogen has not paid the rentals, will be sent out looking for houses to occupy. So we're going to remain with chlorine, which is in group 7. It's in group 7, so if you subtract 7 from 8 to give us 1, so the valence is 1. Sodium also has a valence of 1. So when these guys combine, there is no need of struggling on getting to know the valence. The valences are 1, 1. So I'm just going to write them sodium chloride, like that. Okay, and then plus hydrogen is being formed as a gas, but hydrogen is a diatomic element. So the valence there is going to be written with the subscript 2 because it's a diatomic element. Then B, what you're given is magnesium plus sulfuric acid. We just looked at how to write the sulfuric acid. The sulfuric acid is H2SO4. So how can we now complete that chemical equation? You consider magnesium. Magnesium is in group 2, so the valence is 2. The sulfate is a radical whose valence is 2, that is a 2 which is here. So when these guys combine, what's going to happen is that hydrogen is going to combine with the sulfate, sending hydrogen in exile. But because magnesium and the sulfate both have the valence of 2, so we're just going to combine them as MgSO4 and then plus hydrogen in a similar manner, which is H2. 3, second last is sodium hydroxide. Sodium hydroxide, which is combining now with the copper 2 sulfate. Copper 2 is standing in for the valence of copper. Copper having the valence of 2 and then combines the sulfate, which has got the valence of 2. That's why we cannot see a 2 in here. But the valence for copper is 2. And then the valence for sulfate is 2, so they combine in that way. Now here what happens is what we call a double displacement. The sodium kicks out the sulfur, kicks out the copper from its compound. Then as it goes out, it comes back to pick the hydroxide, which was dumped by the sodium. So what happens is that the sodium removes the copper from its compound, forming the salt copper sulfate, sodium hydroxide. Then as the copper goes out, it comes back to combine with the hydroxide. So what we're going to do here, we're going to have, but remember the sulfate has a valence of 2. Sodium is in group 1, has a valence of 1. So we're going to have sodium with a valence of 2, which is coming from the sulfate. Then NaSO4 that is a sodium sulfate, and then plus copper. Remember, I said copper 2 has a valence of 2, combined with the hydroxide, which has a valence of 1. So we're going to have copper, Cu, and then the OH. This hydroxide will be put in the bracket with a subscript of 2, which is a valence for copper. So this 2 is a valence for copper, but the valence for hydroxide is 1. That's why we have not written it here. But that of copper goes outside, but we cannot remove the brackets because 2 is standing in for both the O and the H. That's why we have written it like that. So it's sodium hydroxide plus copper 2 sulfate forms the sodium sulfate as well as the copper hydroxide, which is an insoluble. I think that one is insoluble. So now the last one, D, we have zinc reacting with nitric acid. This is a very strong acid. Zinc and the nitric acid. But in the nitric acid, there's a hydrogen and the nitrate. The NO3 standing in for nitrate. So the valence for nitrate is 1. The valence for hydrogen is 1. That's why we've not written them like that. But remember, we said zinc, magnesium, they both have the valence of 2. So when zinc removes the hydrogen and sends it into exile, zinc is going to occupy the place where hydrogen was. But remember, this zinc has the valence of 2, so that 2 will be written as a subscript on the nitrate. So what happens here is we're going to have zinc nitrate, zinc nitrate. But this zinc here has a valence of 2, so that valence of 2 will be written as a subscript, but there's already a 3. So to avoid the accidents, I'm going to put a 2 like that. So that's how I can write zinc nitrate, and then hydrogen is produced as the gas. So that is how you can write, and that's how you can complete the equations which have started. So this is sodium hydroxide to form a sodium plus hydrochloric acid, form sodium chloride plus the gas hydrogen. And here we have magnesium plus the sulfuric acid to form a magnesium sulfate plus gas hydrogen, the lightest gas. Then here we have a double decomposition, sodium hydroxide, which is a base, reacts with this salt, which is copper sulfate. Then we form a salt, which is sodium sulfate, and then plus the copper hydroxide. So this 2 is a valence for copper. Then the last one is the last but not the least is the zinc reacts with a nitric acid. Valence 1, is not written. But because this there has a valence of 2, it will bring the disturbance in the combination. And when it comes to combine with nitrate and with a nitrate, that's why the valence for zinc 2 is being written outside the bracket, where with the outside the bracket, which have enclosed the nitrate. Because this 2, which is the valence for zinc, is representing everything on the nitrate. That's why I have put them inside of the bracket. Then the gas hydrogen, which is produced. But that is a diatomic element, so definitely it should have a 2 written as a subscript. But the question that comes in is how come here we've got 2 hydrogen atoms which have combined together, and then here we only have 1. Why? That is now our point of concern in the next presentation. That's where now we should learn how to balance them. So that whatever you start with, the number of entities you start with must be the same as the number of entities that you end with, and that is what we call balancing of chemical equation. So that will be our next presentation. It will not be today, some other day of the week. So that's where we end. Can I have questions if there are questions? Muka. Yes. Question? Any questions?
Sorry.
I have a question.
No question?
Huh? I have a question.
Please ask.
Ish, the network is so bad. Hello?
I can hear you.
Yes, I was saying, why is the hydrogen like cancelled out in some of them? Like, why is it cancelled out when reacting with another?
Cancelled out. What do you mean?
Because like in some, yes, like in some of them, like the ones before, you are like the hydrogen is cancelled out and then it's not like there anymore. But then in others, it's like where you put A plus H2. So that's why I was getting confused.
Have we looked at something like that which you're talking about?
It's fine, it's fine, it's fine.
The
okay.
cancelling comes in when you start looking at the ionic equations. Ionic equation, that is when you
Oh, okay.
the ions which we call spectator ions. You cancel the ions that are present on the left as well as on the right hand side. But we haven't looked at any of such nature. So the cancelling part
Okay.
will not be answered here because we have not done full cancelling. Am I answering the question in line with
Okay.
you asked?
Yes, you answered it.
Okay, then Muka. Muka.